Hey Geometry, last video of a three-part series about circle stuff. So here we are. We're going to talk about circle area and something called sector area. So if you follow along and you were good with the arc length, guess what? Sector area, almost exactly the same. Very, very similar concept. So first, I do want to take a little bit of time here and show you something really cool. I bet you a lot of you know the area of a circle is pi r squared. You probably learned that in probably 5th or 6th grade. And not only that, I know you did it in 7th grade, 8th grade, and we did it back in September. It was part of the menagerie of stuff that was in chapter 1. Boom, circle area, pi r squared. You may not remember when we started chapter 7, way back, it was either probably late February, early March, before all this pandemic stuff began. I told you that every area formula has its beginning with the area of a parallelogram, even the area of a circle. I'm going to show you where that comes from right now. Okay, so how do we get pi r squared? Are you thinking about the area of a parallelogram? Where's parallelogram? Parallelogram, what's it look like? One of these guys, right? Okay. What's the area? Base times height. How do we get pi r squared out of base times height? Well, all we do is slice the pizza. That's all we do. If you take this circle and I slice it, so when you have pizza on the weekends, and you slice with that, or they slice it at the pizza shop, what you get is you get a slice. That slice, that shape, that has a geometrical, mathematical name. It's called a sector. That's called a sector. So right here, I'm going to write that down. This shape is called a sector. So if you really want to bring out your inner nerd, the next time you're having pizza, say, hey, give me a sector. Bound to impress your friends, guaranteed. Okay? So anyway, there's one slice. There's one sector. I'm going to take another sector, another slice of pizza. Boom. Let's suppose I took this, I sliced it into 8, because I think most of the time pizzas get sliced up into 8. Look at what happens. There's half the pizza. I'm just rearranging those slices, those sectors. 1, 2, 3, 4, 5, 6. Oh, I need 2 more. 2 more. Look at how that ends. It ends with the same angle as over here. There's 8 slices. 1, 2, 3, 4, 5, 6, 7, 8 slices. Guess what that looks like? Look at this shape. It looks like a what? A parallelogram. How do I find the area of a parallelogram? Base times height. Again, another one that you learned a long time ago and we did before the closure. Base times height. What's this base here? 1 arc, 2 arcs, 3 arcs, 4 arcs, and there's 4 arcs on top. So the base is 4 arcs. What do all of those arcs add up to? All 8 of those arcs would add up to what? A whole what? A whole circumference, because it would make the whole circle. So this case, it's 1/2 of the circumference. And I'm going to wrap that in a parenthesis. That is the base. The base is 1/2 of the circumference. What's the height? The height. How long is this? Where is that? If you slice a pizza, those two sides of the slice of pizza that come together to make that, it's not quite a triangle. Remember, we call it a sector. Where it comes together to make that point, those 2 sides where it was cut, those are radii. Each one is a radius if the pizza was cut right through the center. So guess what? That's that's an R. The height is a radius. Now I know what you're thinking. You're probably thinking, let's scan in, you're crazy. That doesn't look anything like pi r squared. Well, that's because we have more to do. 1/2, what's the circumference? 1/2, what's circumference from last lesson? Pi times the diameter. Still wrapped in a parenthesis times an r. Now I'm only wrapping that in a parenthesis to show you that that goes with the base. 1/2 c is 1/2 pi d. We have a problem. We have a d and an r in the same formula. We don't want it there. How many radii make a diameter? You should be able to answer that. It's 2. 1/2 times pi times diameter is now what? 2r times this r out here. Okay, I'm taking my parentheses away because now I want to simplify all this. What are you going to simplify? Well, 1/2 and 2, guess what? Cancel. Pi, what's r times r? Pi, there's my pi. What's r times r? R squared. R times r is r to the second power. That's where we get pi r squared from. It's very simple, by slicing up a pizza. Okay? So, let's get back to here. Pi r squared. Real quick problem. Let's take a look at this problem. Find the area. Pi, what's my radius? Again, r is 5. What would d be? D would be 10. I know we don't need the d, but I'm just putting that there so you can think about it. R is 5, so it's pi times 5 squared. That's 25 pi. And that would be square units. In this case, it's inches. So that would be square inches. Now, you've probably heard me say this many times, that I really don't care about the units a whole lot. We'll let the science people worry about the units, chemistry, physics. I'm not too worried about it. Unless we need them, then I'll emphasize them. So 25 pi. What's 25 pi? I don't know. 25 pi, let's see, that's roughly 25 times 3. I think it's around 78. So 25 pi, 78, oh look at that. Well, I was right. 78.54. Okay, so 25 pi is approximately 78.54. So if you're asked to round it off to 2 places, boom, there's your answer. If you're asked to leave it in terms of pi, 25 pi it is. Okay, so again, that's something you've done before. In fact, you probably did that with in 6th grade with the late great Mr. Jim Huffman. So anyway, let's get rid of that. And now let's talk about sector area. Okay, sector area. Sector area. If you followed the arc length lesson, the last video in this 3-part series, if you followed the arc length lesson, this is no different. Except we have pi r squared instead of pi times d. So here's what we have to do. We got to put in that. How big do we want that? What angle do we want there? I don't know. Let's make it, see, I just want to move the 5 inches out here. 5 inches. How big do we want that angle to be? I don't know. It looks like it's close to being a right angle. So let's call it 75 degrees. 75 degrees. So again, A, B. Find the area of sector that's bounded by arc AB. Okay, so we want to find the area of that sector. Okay, what's a sector again? Boom, I left it up there. A sector is your slice of pizza. So what are we going to do here? Well, what's a sector? A sector is part of the area. Well, what part is it? And if you're thinking ahead, it's the angle part. So how do we do this? 75 degrees divided by 360 degrees times pi r squared times the whole area. This is part of the whole area of the circle. Now when we did the whole area of the circle, remember I said it was about 78, it was 78 point something, 78 point, still on my calculator, 78.54. We got to get a number smaller than 78. In fact, it should be considerably smaller. It should be less than a quarter of that. So let's see, half of 78, you're probably looking 30, 38, 39. Then you're going to go a quarter of that, so half of 38, 39, you're looking down, you know, it's going to be significantly smaller. So let's see, pi r squared, we got 75 divided by 360 times pi times, what's my radius? My radius is 5. If you like the little box, make it for yourself, okay? 5 squared. So we got 25 times pi. Well, we already know what all that was. So we got 75 out of 360 times, what was it? It was 78.54. This was 78.54. Okay, so all you got to do is crank that out. 75 over 360, not an easy reduction of a fraction. But let's get this one as a decimal. So we got 78.54 times 75, boom. And then we're going to go divided by 360, and we got about 16.36. So this is about 16.36. And again, this is square inches, but as I mentioned previously, I'm not too concerned about units. I'm just concerned about the value for right now. Okay, so 16.36. So that was roughly a quarter. So if you do about 16 times, you know, it's going to be up there. It's not quite a quarter because it's only 75 degrees. 90 degrees would be a quarter. So I hope you see the parallel, no pun intended because it is geometry. I hope you see the parallel between finding sector area and finding arc length. They're the same thing, except for they're both angle divided by 360. If you want to write that down, angle divided by 360 times, in this case it's pi r squared. Okay, so this was sector. When we did arc length, look at how close it looks. It's angle out of 360 times pi times d. Look at how close those two formulas look. What's the difference? One time we're using circumference, one time we're using area. Okay, very, very similar. Now, of course, we're gonna kind of put these problems. We're gonna use these as tools and use them in problems that are a little bit bigger than themselves. But here they are. That's pretty much how easy it is. Got to have a calculator. Okay, don't care what kind it is. All of you had one in class. You can use your phones because most of you probably have a phone anyway. On your Chromebook, I'm sure you can download. If you don't have a calculator handy, you can download a calculator on the Chromebook. I'm sure a quick Google search will get you one somewhere. Okay, so until next time, stay safe, and we'll see you. Bye.